Here's a claim that sounds impossible. A robot priced at $16,000 that can take a full-force kick to the chest, recover its balance in a fraction of a second, and keep walking like nothing happened. Most humanoid robots you've seen online are handled carefully, guided by technicians, protected from anything that might make them fall. This one was built to be hit on purpose. This is the T800, built by a company called Engine AI. And the reason it's making engineers at other robotics companies nervous isn't the punch it can take. It's the price tag attached to taking it. By the end of this video, you'll understand exactly how a robot this durable ended up this cheap, and why the strategy behind it might be more disruptive than the robot itself. Most Americans who followed the humanoid robot race know the big names: Boston Dynamics, Tesla's Optimus, Figure AI. Engine AI is a newer, smaller player out of Shenzhen, founded only a few years ago, and until recently, most people outside the robotics industry had never heard of it. That changed the moment footage surfaced of this robot's own inventor walking up to it on a testing floor and kicking it as hard as he could, directly in the torso, on camera, on purpose. The robot staggered, recalculated, and was standing normally again before the clip even cut. That single moment did more for Engine AI's reputation than any keynote presentation could have, and it turned a small, relatively unknown startup into one of the most talked about names in robotics almost overnight. That overnight attention came with real money behind it. Engine AI has pulled in venture funding from Chinese investors, betting specifically on humanoid robots reaching commercial viability within the next few years, not the next few decades. That's a meaningfully different bet than the one most American robotics investors have historically made, where humanoid platforms were funded as long-term research projects rather than near-term products with a price tag attached. Here's the engineering behind that recovery. The T800's frame is built from aviation-grade aluminum, rated to handle joint torque above 450 Newton meters. For comparison, a trained human's kick generates somewhere in the range of 200 to 300 Newton meters of force. In plain terms, this robot's joints are built to absorb roughly double what a professional fighter can throw at it and keep functioning afterward. Balance recovery is where the real engineering shows up. The T800 uses 360-degree LiDAR combined with stereo cameras, recalculating its center of balance hundreds of times every second. When it gets hit, the system doesn't wait to fall and then stand back up the way older robots do. It's already adjusting mid-impact, shifting weight through the hips and ankles before the person watching even registers that something happened. All of that sensing has to be processed somewhere, and this is a detail most coverage of the robot skips entirely. The T800 runs its balance and vision processing on an onboard AI compute unit, not a remote server sending instructions over a wireless connection. That distinction matters more than it sounds. A robot that depends on a cloud connection to process a fall introduces a delay measured in tenths of a second, an eternity when the robot is actively toppling over. By keeping that calculation on the robot itself, the reaction time drops to something close to a human reflex. Endurance matters just as much as durability. The T800 runs on a solid-state battery capable of 4 hours of continuous dynamic motion. Not 4 hours of standing still, 4 hours of actual walking, balancing, and absorbing impacts. Most humanoid robot demos you've seen online last a few minutes before needing a recharge or a battery swap off camera. 4 hours is close to a full working shift. For context, a human security guard working an 8-hour overnight shift needs breaks, benefits, and a paycheck every single week of the year. A robot running 2 consecutive 4-hour cycles, with a battery swap taking roughly as long as a coffee break, needs none of that. That math is exactly why several Chinese logistics and manufacturing firms have reportedly already begun quietly evaluating T800 units for overnight facility patrol and warehouse monitoring, long before any consumer version of this robot exists. Now, here's the part that actually explains the $16,000 price tag, and it has almost nothing to do with the robot itself. It has to do with what Engine AI didn't have to build from scratch. China's supply chain for electric motors, servo actuators, and lithium battery cells, largely developed for the electric vehicle and drone industries, already exists at massive manufacturing scale. Engine AI isn't sourcing custom, low-volume robotics components the way an American startup often has to. It's buying parts that are already being mass-produced by the millions for cars and consumer electronics, and adapting them for a humanoid frame. That's the actual unlock. The hardest, most expensive part of building a robot like this was never the robot. It was the supply chain underneath it, and that supply chain was already built before Engine AI ever touched it. To put that $16,000 figure in context, Boston Dynamics' Atlas robot has never been sold commercially, but industry estimates have placed comparable research-grade humanoid platforms well above $150,000. Tesla has publicly discussed a long-term target price for Optimus somewhere in the $20,000 to $30,000 range, a target it hasn't hit yet at commercial scale. Engine AI isn't just competing on capability. It's already undercutting where its competitors are hoping to eventually land. There's a second economic advantage that doesn't show up in the sticker price at all: repairability. Because the T800 uses many of the same mass-produced motors, sensors, and battery modules found across China's EV and drone industries, replacement parts are neither rare nor expensive. A damaged actuator isn't a custom, months-long backorder the way it can be for a hand-built research robot. It's closer to swapping a part off a shelf. Over the working life of a robot that gets hit on purpose as part of its own testing philosophy, that difference in repair cost and downtime adds up fast. And that decision to build for punishment instead of precision is only the first part of the story. There's a second part, and it's the reason some robotics engineers are calling this company's whole approach reckless. If you want to see exactly what that means, stick around and hit subscribe, because it gets more interesting from here. Most humanoid robotics companies test in controlled environments: padded floors, safety harnesses, technicians standing by to catch a robot before it falls and damages an actuator worth tens of thousands of dollars. Engine AI does the opposite. In February of 2026, the company launched something called the Ultimate Robot Knockout Legend, an actual combat league where humanoid robots are pitted against each other in unscripted physical matches with real contact and real falls, drawing in multiple competing robotics teams to participate. That sounds like a stunt. It's actually a data strategy. Every fall, every miscalculated step, every off-balance recovery generates real-world failure data that a padded lab environment simply cannot produce. Industry estimates suggest this kind of adversarial, real-world testing can compress a robotics R&D timeline by as much as 30% compared to controlled lab testing alone. Because the robot is being forced to solve problems engineers wouldn't have thought to test for. Compare that to Unitree, one of Engine AI's closest competitors, which chose an almost opposite strategy. Unitree's robots have performed choreographed, rehearsed routines, most famously in a televised Spring Festival Gala performance broadcast to hundreds of millions of viewers. That's a demonstration of precision and control. Engine AI's Combat League is a demonstration of resilience under chaos. Neither strategy is wrong. They're simply optimizing for different outcomes, and the industry is watching both experiments play out in real time. The most viral piece of footage tied to this robot wasn't from the fighting league at all. It showed a T800 unit walking alongside a police formation in Shenzhen, matching their pace step for step down a public street. To a lot of viewers, that clip looked like proof of an autonomous robot making its own decisions in a live public setting. It wasn't. The routes, the pacing, and the movements in that demonstration were pre-programmed. The robot wasn't observing the officers and deciding how to respond to them. It was executing a rehearsed walking pattern designed to look impressive next to a formation of real people. That distinction matters, because it's the difference between a robot that can operate independently in the real world and a robot that can convincingly perform the appearance of operating independently in the real world. Right now, this technology is still much closer to the second category. That's the honest limitation worth sitting with. A machine engineered specifically to absorb impact and keep functioning is not by itself a machine that's ready to make its own decisions around unpredictable crowds of people. Durability solves one very real, very hard problem in robotics. It doesn't solve the much harder problem of judgment. There's also a broader conversation happening in robotics right now about exactly this gap. Autonomous vehicles spent close to a decade earning public trust before regulators and everyday drivers treated them as safe neighbors on the road. Humanoid robots that can survive contact with the real world are likely headed toward a similar gradual trust-building period, not an overnight one. So where does a robot like this actually go to work first, if not into unpredictable public spaces? The realistic near-term answer is far less dramatic than a police escort: warehouses, construction sites, and industrial facilities, where the environment is at least semi-controlled, but still physically demanding enough that durability matters more than conversation skills. A robot that can absorb a dropped pallet, a collision with machinery, or a fall on a wet floor and keep working is worth far more on a factory floor than a robot that can hold a conversation but needs to be babied around hazards. That's a considerably less glamorous story than the viral clips suggest, but it's also a far more immediate and profitable one for whoever gets there first. So what rule did this actually break? Not a safety rule and not a performance rule. It broke an assumption almost the entire robotics industry has quietly agreed on for years: that a humanoid robot has to be treated like something fragile, tested carefully, protected from real-world contact until it's proven safe enough to risk. Engine AI built the opposite kind of robot first, and only afterward is anyone asking whether it should have autonomy to match. That gap between what this robot can physically survive and what it's actually allowed to decide on its own is not a footnote. It's the whole story, and it's the one most viral clips of this robot leave out entirely